Well, the aim of today's lecture is to do a midterm exam rehearsal, right? So you have 3 questions. The first of all, that is the 40% of the mark of the exam, is a binary optimization problem. Then you have the building of a Petri net by means of the HPSIM software. Here is question 2, only 30 minutes for this, right? And finally, the third question, it's about a 40% of the mark of the exam, right? You have 1 full hour for this problem. This is only an estimated time, right? If you have 30 minutes in here, well, this should be done in less time than 30 minutes, and this should be done in less time than 60 minutes, right? So, well, this is only for your knowledge, right? What I think is about 60 minutes, right? This final problem is about sim event model analysis, right? Well, I'm going to start with this. I'm going to read the statement. I'm going to explain what to do. I'm going to show you the model. I'm going to explain every part of the model, because as I told you, the midterm exam will be very similar to this rehearsal, right? So this is not a misleading exam. It's a specific clue about what the midterm exam will be, right? Well, so first of all, we're going to read the statement. This problem is closely connected with problem number 2, because problem number 2 is about a railway station, right? Well, then you are asked about the analysis of the sim events model. The model is this, Terrassa railway station. If you go to the virtual campus, you will see that you have here the model and the M file, the corresponding M file, in order to run this model several times, right? Well, then, about this problem is about the management of the 4-platform system here in the Terrassa main railway station. And track number 5 is for maintenance tasks. As you can see here, we have 5 platforms, 5 tracks, as you can see, but track number 5 will not be considered in this problem, because it's only for maintenance, right? So only tracks from 1 to 4 will operate in this problem, right? So then, here you have the schematic layout of the different available platforms, and pay attention to the set of points, the railroad switches at both platform ends. As you can see here trains go to Barcelona, here they come from Barcelona, and here they are going to Manresa, Lleida, and so on, right? Well, the general idea is that incoming trains can be from Barcelona or from Manresa, right? And then you have several switches in here. So every train, we will consider that every train can be placed, can stop at any of these platforms, right? So it's not important if the train comes from Manresa or from Barcelona, right? Well, so first of all, every entity, every train in the model has several attributes. First of all, the attribute 2 is the train destination. Barcelona will be number 1, Terrassa will be number 2, and Manresa will be number 3. That's because trains that are going from Manresa to Barcelona, some of them stop in Terrassa for a long stop, right? That's the general idea. So all the trains that come from Manresa can go to Barcelona with a short stop in Terrassa, or to Terrassa with a long stop in this city, right? And then the other way around. The trains that are coming from Barcelona to Manresa, they can have 2 different kind of stops. First of all, they can stop for a while in order to the unloading and loading of new passengers, right? And then go to Manresa, or maybe they have a destination that is Terrassa, and then they have a long stop, right? Then you have two different lengths for the trains, right? You have simple, number one, or double, number two. As you may know, we have two different train lengths, right? Well, and then some considerations must be taken into account before starting with this problem. First of all, it will be considered that the railway station will be operative for passengers 12 hours per day, right? I know that this is not true, but this is not true for real life problems, right? But for this simulation, we will consider this. And then the other 12 hours per day, we will have maintenance, right? So no passengers are admitted, right? Then 1 out of 5 trains with Barcelona as origin and in Terrassa railway station. So we have the 20% of trains that come from Barcelona stops in Terrassa, right? And only trains with Terrassa as destination will be affected by the cleaning process, right? By the cleaning process, which lasts between 10 and 15 minutes. So we have a cleaning process that is done with long stay trains, right? That's the general idea. Then trains with no need for the cleaning process will stay between 2 and 4 minutes on the platform for the unloading of passengers and the same time for the corresponding loading, right? The length of the train, single or double, has no connection, right, with its origin, destination, but it's strictly connected with the number of cleaning service workers needed, right? Well, in order to be so clear, you are not expected to build a model, right? This is only an explanation of the model. If you prefer, you can go directly to the model, right, and go on, right? Then, every platform can admit only a single train, whatever its length is. Simulation time units are minutes, and simulation starts on Monday morning and ends on the night of, from Sunday to Monday, right? So what about the questions? You are asked to answer the questions listed below, these 3 questions. As you can see, 4 points. Every question starts with the original model, this model, and histogram results must have 5 classes. So when you will be asked for the number of replications, this sentence tells us that we need 25 replications, right? Because the number of classes is the square root of the number of replications. You with me? So, first of all, 2 points. Run the simulation model with different platform assignment strategies. Equiprobable, and save the model this, Terrassa railway station. A is because here we have an A, and I because here we have an I, right? And then the second question will be with A double I, because here we have A and double I, right? So first of all, equiprobable. As you may remember, I told you about this during the theoretical lectures, right? So the exam will consist strictly on these concepts I have dealt with during my theoretical and lab sessions, right? So that's why, if you remember, that's why I had like a specific explanation on what about equiprobable means and what about first spot that is not blocked is about, right? So let's open the model, right? Here we are. And let's have like an overall view of what is it doing, right? Well, first of all, here, the same as always. This is not the first time you see this, like the shift generator. You remember? This is the clock time. You divide this clock time about the shift length. Remember? Morning, night, morning, night, morning, night, and so on, right? So that's why here we have 12 multiplied by 60. Remember that the simulation time is in minutes, 24 hours, 60 minutes per hour, 7 days a week, right? Fine. Then remember the floor, and we add 1 in order to have here numbers from 1 to 14, right? Then let's have a look at the resources. Remember, red doctors, orange doctors, yellow doctors. So at the end, the midterm exam and this rehearsal will be very, very, very similar to this model that we have dealt with in the past. That is the emergency stage model, right? So then, here we have the cleaning workers table. Let's double click here. And these are, in a similar way to the emergency stage problem, these are the values of all the resources, as you can see here, all the resources in this pool, right? These are the cleaning workers. So we have 2 workers on Monday morning, 1 single worker on Monday night, 2 workers Monday morning, Tuesday morning, 1 single worker Tuesday at night, and so on, right? That's the general idea. Then remember that the statement of the problem told us that simulation starts on Monday morning, right? And ends on the night from Sunday to Monday, right? Fine. So here we have the number of the amount of resources, the amount of cleaning workers, right? Remember, if a train is a long train, we will need 2 workers, right? If the train is a short train, then we will have a single worker, right? But be careful, just because at night we will have only maintenance tasks, right? Well, then here we have 4 platforms that we have discrete unit, and the amount is 1. We have a single platform, right? That's why we have no external input. One platform, and then 1 and 1. So a single platform is defined, right? Then, like always, the resources, the number of resources in use, and then the percentage, right? Fine. So now let's have a look at how do I view all the entities? How do I generate all the entities? Well, first of all, here we have the means for exponentially distributed random numbers. As you can see here we have the means for the arrival of trains for the whole week. So the mean value between arrivals on Monday morning is 10 minutes. At night, it will be 6 hours, as you can see here, right? Because it's only for maintenance, right? Then, despite this is you are expected to understand this like an academic problem, right? Obviously, it has its translation on real life, but now we will not be so we will not discuss about if this number is true or not, right? So the general idea is passengers, maintenance, passengers, maintenance. And on Saturday and Sunday, the frequency decreases, right? So the time between arrivals is bigger, right? That's the reason. Fine. Then the function that will calculate the probability density function based on these mean values, right? So as you can see here, the function is time between train arrivals, and we have an exponentially distributed function. Remember, exponentially distributed functions can be stated as the minus natural logarithm of a uniform probability density function between 0 and 1, and then u, that is the input of the function, will be the mean value. Remember, the u is the mean value that is served by means of this lookup table, right? So that's why this function takes the u in here, and this u is the mean value for the exponentially distributed probability density function. This is a single number, one row, one column of a uniform random number, right? And this is the minus natural logarithm, right? In MATLAB, this is the natural logarithm, right? So for this is the common logarithm, the base 10 logarithm, right? So I hope that you catch the difference, be careful, right? But well, you will be given this model, so nothing to do with this. This is only for understanding, right? So, and this will be the output, obviously, right? Then this output will feed the time-based entity generator. And this time-based entity generator, the intergeneration time, so the time between train arrivals, will come from port T, right? Fine. Obviously, this is a long and thorough explanation of the model. For the exam, you're not expected to explain anything about the model, right? This is only for understanding, because the midterm exam will be very similar to the emergency stage, very similar to this railway station and the like, right? Well, afterwards, here, once the entity is generated, the entity goes through the setting of attributes section, right? Here we set the length, here we set the from attribute, and here we set to attribute, depending of if the train comes from Barcelona or from Manresa, right? The destination will be Terrassa or Manresa in here, and Terrassa or Barcelona in here, right? So nothing to do on that, right? It's only, as you remember, probability density functions, then the probability is the same than the assignment of a color for all the patients in the hospital. You remember? Right. Afterwards, a path combiner, right? All the entities, despite they go through this or through this, are combined in the same path. So all the entities will go through this track, right? And then here we have an output switch. Now this output switch is configured as round robin. Remember the round robin strategy. And then, as you can see here, the entities are splitted into different platforms, 1, 2, 3, 4, right? Then here you have the queues. Can you see the queues? For every resource acquired, right? And here we have the average time they wait, the train waits for the platform to be empty, right? Is the same that the emergency stage problem, right? So here you have, for every resource acquired, you have the mean time. Here you are, the mean time. That is the average wait. The mean time they wait for the platform to be empty, right? Then the process of the unloading of passengers is between 2 and 4. Remember about the statement. Remember the seat. All seats are different in this simulation. And then here we have, afterwards, an output switch. This output switch will be based on attribute, because depending on the train destination to, right? Depending on the train destination, if destination is Terrassa, 1 is Barcelona, 2 is Terrassa, 3 is Manresa. I know this because of the statement of the problem, right? 2, Barcelona, Terrassa, Manresa, right? So only trains that have destination, that have Terrassa as destination, will have the cleaning service process, right? So they acquire cleaning service workers and they release cleaning service workers. And the time for the cleaning process is between 10 and 15 minutes, right? Well, how many cleaning workers this process needs? Well, it will depend on the attribute length, right? It will depend on the attribute length. Why? Because as you can see here, and here, trains with no need, the length of the train, single or double, has no connection with its origin destination, but it's strictly connected with the number of cleaning service workers needed, right? So if the length is single, one worker. If it's double, 2 workers, right? Well, afterwards, after the cleaning service has finished, or if it's a short stop, so if destination is Barcelona or Manresa, they go directly with no cleaning service directly to a path combiner. Here we have the cleaning service in Terrassa. Here we have no cleaning services. So then we load new passengers and then we release the platform, right? And the same goes for platform 1 to 4, right? So let's go now. This is the whole model, right? So the model for the midterm exam will be very, very, very similar to this. So this is a true rehearsal. So then we are asked to use different platform assignment strategies. So for equiprobable and the first spot that is not blocked, we will be expected to do the following. Remember that the output switch that splits every arriving train to different platforms is this in here, right? So that's the aim for this question, for question number 2, to change this into equiprobable and the first spot that is not blocked, right? So you're expected to change this. Well, now it's equiprobable, okay? And then we save the model, obviously with a different name. So the new name will be what? Terrassa Railway Station AI. So I will copy this. Then you're expected to do the following. Save as. Then I'm going to change the model, right? SLX. I'll change the model. Fine. And now remember that you have a file called run the model several times and get statistics Terrassa Railway Station, right? Well, but this file is strictly using the original model, Terrassa Railway Station. Now it's AI, right? So we will open this model, and then don't forget, set param, I will change the name of the model. Get param, I will change the name of the model in here. And get param, I will change the name of the model in here, right? And then the results will be about this model. Please don't forget this part, right? So then, if you have the model saved in here, well, sorry, the name of the model is something weird. It's Terrassa Railway Station AI, right? Fine, I save this model. Once it is saved, now I can run this file. I run, and obviously, what is the number of replications? You're expected to put 25. Why? Because I want square root of 25 number of classes, right? But I'm gonna do it only by 9 simulation in order to be so short. As you can see, model is running, and the model is the specific model. This is only for checking, right? It's working. You can, for example, check the use of resources, that it's going obviously so different for every replication, right? Obviously, every time is different, right? The cleaning service is the blue line. Well, the cleaning service is shared with other sections of the railway station, right? So you will see that it's under the 40% the most of the time, right? You will see here under the 40%, but it's because they have other tasks, not only cleaning the train, right? That's the general idea. So now we are going to the end, last replication, and we will get the statistics automatically. We are over, and here we have the histograms, right? About the average use of platform number 1. So if you go to the railway station, you will see that not all the time there is a train in the platform, right? So here we have different, as you can see, different uses for platforms, right? And then the cleaning utilization percentage. As you can see, it seems like a triangular probability density function, right? Well, the general idea is that here you will have 5 classes, and you're expected to compare this with this, right? You change the name of the model, you simulate, and so on, right? Fine. So let's go now to the second question. Change the mean value for train arrivals from 10 to 7 minutes Monday to Friday, and from 25 to 15 minutes on weekends. Discuss this proposal for the increasing of the frequency for the incoming of trains, right? So you are expected to, first of all, every question starts with the original model, right? And histogram results must have 5 classes. So you're expected to close this model, right? Just open back the original model, right? You open the original model, and then you are expected to change these train arrivals, right? On weekends, it will be 15, 15, from Monday to Friday, 7, 7, 7, and 7, right? So you change this, and I want you to compare this new proposal with the original one, right? And obviously, the original one will be with this, the round robin, right? I know, because this is the original model, right? So for the midterm exam, in order to be so clear, every question will start with the original model, right? It will not be Terrassa railway station, it will be another one, but all questions will take as the starting point the original model, right? And then you're expected to discuss new proposals, right? Then, so this is a very quick question because only you are expected to change this, the incoming, right? The frequency for the incoming of trains. And the final question is that platform 4 is being considered as a railway service track for maintenance. Modify the corresponding model, here you have the name, right? And discuss about the effects of this strategy and conclude if you agree with it, right? So we are expected to do the following. Now, we will not have 4 platforms, we will have only 3, right? And then you're expected to obviously delete everything about platform number 4. I want you just to compare the original simulation with the new proposal. So what do I want to assess is only to check if it's possible to have only three tracks for passengers, right? 3 platforms for passengers. So that's the general idea behind this problem number 3, right? It's not about building a model. It's only about you have a model, just do the analysis. That will be the useful part of this in your future as engineers. Well, let's go now for problem number 2. It's 2 points and 30 minutes is the estimated time in order to solve this problem. It's about building of a PetriNet in the HPSIM environment, right? And as you can see here, it's strongly connected with problem number 3. We are asked to build a PetriNet model on the train traffic management for platform number 2 in the Terrassa North railway station. Well, platform number 2 allocates trains to both directions, Barcelona-Manresa, right? This specific transform is used for quite long stops where the cleaning service takes place. This is true, right? Then the process starts. So as you can see, this part of the text is in boldface in order to tell you directly that this will be the explanation of the PetriNet we are expected to build, right? So the process starts with a train approaching the station. When platform 2 is empty, the train gets directly to the platform. In those situations where an approaching train finds the platform busy, it is expected to wait nearby the station, right? Once the train stops and the passengers get out from aboard, the driver and the assistant both get out of the driving cabin, right? So here in the driving cabin, we have the driver and an assistant, right? So they get out of the driving cabin once the passengers got out from aboard. Then the cleaning process starts. 2 cleaning service workers are needed for this task, which lasts between 7 and 15 minutes. During the cleaning process, the driver and the assistant both go to the station office. So they are out of the train, obviously. They have a break and become ready for the new departure. Just after this service, the 2 cleaning service workers become idle, and both are ready for another train arrival. Once the cleaning service is finished, a driver plus assistant pair, not necessarily the same that in the arrival and the arriving train, are assigned to the departing train. The process ends with the train departure, right? So The list of resources in this railway station is single platform, number 2, 3 cleaning service workers, a single train driver, and 2 driver assistants are always present at the railway station office, right? This is a very important point because they are always present at the railway station office, right? So this single train driver and 2 driver assistants, right, are not the train driver and the assistant in the incoming train, right? So, in other words, when a train arrives and stops at the station, then the unloading of the passengers is done, right? Then this driver and this assistant go through the to the office, right? So then we will have 2 train drivers and 3 driver assistants, right? That's the idea. This information can be extracted from the text and this list, right? Because they are always present. So when the train arrives, a single train driver and 2 driver assistants are present in the railway station office, right? So these 2 must be added, 1 in here and 1 in here, right? So the Petri net starts with the train arrival, 1 single train arrival, as you can see here, and the train departure, right? That's the idea. Obviously, here we have nothing to do with the loading of passengers, just because here we have between 7 and 15 minutes, and the loading of passengers can be done during the cleaning process, right? So it's time enough, right? That's why the loading of passengers is not a specific process itself, right? So you're expected to open the HPSim simulator editor, right? Simulation editor, and then to build this model. At the end, remember, just put the resources aside, and then the main flow of entities from here to this end, right? And remember, use the resources when you need them, right? That's the general idea. Well, this has been the explanation for problem number 2, that is strongly connected with problem number 3 in the exam. Now we're gonna go to problem number 1. Well, so let's go now for problem number 1, that it's about a binary optimization problem. As you can see here, it's a long problem, right? 4 points, 60 minutes is the estimated time in order to solve this problem, right? Well, let's check the statement. Here we have, you are the engineer in charge to assign the working shifts for the COVID-19 test analysis laboratory, right? 4 laboratory assistants, A, B, C, and D, must be assigned 2 shifts each, right? So that's the main difference with, for example, the office assignment problem. For the office assignment problem, you remember we have 1 worker assigned to 1 seat, right? Here, 1 worker, 1 lab assistant will be assigned 2 shifts, right? Not 1, 2, right? Here we have the first difference with the office assignment. Well, the 8 working shifts span from Monday to Thursday. Here we are, the 8 working shifts, right? Then we have Monday morning, Monday evening, Tuesday morning, the same evening, Wednesday and Thursday, right? Well, and as you can see here, we have the preferences of these assistants. It's the same as the office assignment problem, right? As you can see here, Beth prefers to work on mornings, right? In front of evenings, 20, 10, 25, 25, 20. No one at the end, no one wants to work on Thursday evening, right? Yeah. We don't know why, but they don't want to work there. Then you can make the difference between the assistants according to their academic status or level. Adam and Dave are undergraduate students, but Beth and Caroline are master students, right? So you can make the difference between the assistants according to the academic status. So this connects directly with the seniority. You remember? Here we don't know how long they have been working in this laboratory. But the important thing is that Adam and Dave are undergraduate students, and Beth and Caroline are master students, right? Well, you can put undergraduate students just before the master students or the other way around. The only thing is that you can make the difference between the assistants according to this academic status, right? I don't know if you will reinforce undergraduate students or master students. It's up to you, right? The statement of the problem has no explanation on that, right? It's not a specific information. You with me? That's the idea. So this sentence is only for making the difference between Adam and Dave preferences in front of Beth and Caroline preferences, right? I don't know if you want to consider master students in front of undergraduate students or the other way around. That's not important. The important thing is that you make the difference between them, right? Then you must avoid 2 consecutive working shifts assigned to the same assistant. So if Adam is assigned on Monday morning, Adam will not be assigned on Monday evening. If Adam is assigned on Tuesday morning, Adam cannot be assigned on Tuesday evening, and so on, right? The same goes for Beth, for Caroline, and for Dave, right? Finally, Beth must be assigned to those shifts immediately after Adam's because Beth works on Adam's results, right? So this 2 constraints. The first one connects with, remember, the cleaning process on the milk derivatives process. That's the idea. Or, for example, the different customers in the textile manufacturing process, right? Then this second constraint connects strictly with the neighbors in the office assignment problem. So at the end, all these constraints, these constraints and this constraint connects strictly and directly to a previous problem that we have dealt with. And then finally here, the cause function, this is the seniority. It's not strictly the seniority, but it plays the same role as seniority in the office assignment problem. And these are the preferences for the cause function, right? So you're expected to formulate and solve the important thing, solve the corresponding binary optimization problem within the MATLAB environment. Despite this problem could be manually solved. So an M file is expected, and the weights for the assessment are, first of all, if you build the cost function currently, it's the 20% of 4 points, right? So it's 0.8. Then the 60% is about the constraints. So it's about 2.4 points, right? And finally, the 20% of the total mark of this problem is about the interlim proc calling and the interpretation of the solution. So at the end, which assistant goes to every shift, right? That's the idea. Fine. So we have 4 assistants, 2 shifts per assistant. We have 8 possible shifts. So all of them will be filled with an assistant.